Hey guys, so this is Unit 6 Video 1. This is here just as a supplement to the lecture we had in class. It's the exact same lecture we did in class. I just want to make sure you guys had it available online in case you're absent or you wanted to rewatch it or whatever. Okay, so we're starting a new unit on momentum. Okay, and today we're going to talk about momentum and impulse. So you're going to compare the momentum of different moving objects. We're going to identify and list examples of changes in momentum, and we're going to describe changes of momentum in terms of force and time. Okay, the vocab for today. Okay, so momentum, we use the letter P. I know that's weird, but if we use M, it's like mass. So we really can't do that. All right, so we use P, and it's a lowercase p. It is a way to describe all the motion in the world, and it's the product of mass and velocity. So it's just a quantity of motion using mass and velocity. So P equals M times V, okay, where P is momentum. Okay, M is mass, V is velocity. The units are going to be just like they look, so mass units are kilograms times velocity units, which is meters per second. Okay, so the units for momentum are kilogram meters per second. All right. All right, so momentum, like most other things in this class, is a vector. Okay, meaning it has direction. It has the same direction as the velocity. It always points in the same direction as velocity, but the size of the arrow is dependent on velocity and mass. So in order to have more momentum, you would need to have more velocity and mass together versus just more velocity or just more mass. Okay, so since it's mass times velocity, just having bigger velocity doesn't necessarily mean that you have more momentum, because if the other object has more mass and it actually outweighs the velocity, then that one might have more momentum. Okay, so find the momentum of a 1,000-kilogram car driving at 15 meters per second in reverse. So it's driving this way. Okay, its mass is 1,000. Velocity is 15. Okay, and actually, since it's driving backward, I'm going to make sure I put a negative on the velocity. Okay, and a 10-gram B, so mass is 10 grams, so that would convert to 0.01 kilograms, okay, flying at 15 meters per second to the left, so it's also flying this way. Velocity is also negative 15, okay. Draw arrows and vectors to describe both objects. All right, I drew the momentum smaller for the B because its mass is so much smaller. All right, so to find the momentum of the car, P equals mv. I'm just going to do 1,000 times negative 15, which gives us negative 15,000 kilogram meters per second. Okay, and for the B, same equation, 0.01 times negative 15, and we get P equals negative 0.15 kilogram meters per second. Okay, so that's how you solve for momentum. Now, an object's momentum can and most likely will change. Okay, this happens when a force is applied for some amount of time. So to change the momentum, you have to change the velocity or the mass of an object. Okay, most objects we just change the velocity because it's easiest, right? So if I want to change the momentum of my car, I press on the brake, I exert a force, and I change the momentum or I change the velocity of the car. Now, the change in momentum is caused by a force applied over some time. So in order to slow my car down and change its momentum, I have to apply a force, the brakes, over some period of time. This change in momentum is called impulse. Okay? The change in momentum is called impulse. Everything here comes from Newton's second law. You should try to think in terms of F equals ma. Okay? The equation for impulse, we use big I, okay, which makes sense. And it's the change in momentum. So we can write it as change in momentum. But it's also equal to force times time. Okay? The units for impulse are the same. Since it's change in momentum, they're the same as momentum. So it's kilogram meters per second. Okay? All right, so let's do an example here. So a 0.05, so mass equals 0.05 kilogram baseball travels towards a batter at 15 meters per second. Okay? is hit into the outfield at 30 meters per second. So you can imagine the ball, here's the bat, okay? Ball's traveling toward the bat. Bat hits the ball. Ball is then after that collision, the ball is actually going to go left, okay, at 30 meters per second. All right. So initially I have the ball going to the right. If the ball is then hit into the outfield at 30, I'm going to assume that the bat hit the ball the opposite direction at 30 meters per second. So this is actually going to be a negative 30 meters per second, okay? Find the impulse of the ball. Well, the mass stayed the same. Okay. Oops, that's the wrong unit. So the impulse is going to be the change in momentum, which is mass times velocity final minus mass times velocity initial. Okay, and we can actually add that over here, right? V final minus mass V initial, okay? That's one of the equations. The other equation is I equals force times time. Depending on what you're given, you'll use these two different equations, okay? This is just a repeat of what's here. So in this case, we're not given the force of the time, so I'm just going to go ahead and plug into this equation. So for impulse here, I have mass, which is 0.05, times final velocity, which is negative 30, minus 0.05 times initial velocity, which is 15. 0.05 times negative 30 is negative 1.5 minus 0.05 times 15, which is 0.75. So in this case, impulse is negative 1.5 minus 0.75. Oops. And I get negative 2.25 kilogram meters per second. Okay, so that's the impulse of the ball. Let's do another example here, or let's continue this here. Now, if the baseball from above is in contact with the bat, sorry, I got interrupted. So anyway, if the baseball from above is in contact with the bat for 0.001 seconds, that means the time is that amount, how much force did the ball exert on the bat? Okay, or bat on ball, right? Same thing, okay? All right, so we want to know the force. The way we connect this to what we found earlier is that we know impulse is equal to force times time. Okay, we found the impulse before. It was negative 2.25. Okay, we know the time. So if we plug this in, we get negative 2.25 equals force times 0.001. Divide negative 2.25 by 0.001. And you get the force is equal to negative 2250 newtons. The negative is just the direction. Oops, sorry guys. Sorry, so this was the impulse equals the force times the time, okay? And then I just divided. The negative is just the direction because the bat hit the ball to the left, okay? And so it's just the direction, all right? So that's it. That's momentum and impulse. This is, again, just a supplemental lecture. We went over this in class. And we will go on to lecture 2 next class. All right?